Okay, so let's try this again. So immunity is the next section that we have to talk about, and immunity is the body's ability to fight diseases and things like cancer. So it can be brought about naturally. So it could be that you got an infection. So maybe you got chicken pox. So after you got chicken pox once, then you're immune to them. It could also be brought about artificially by either a vaccine, or we could give you antibodies to something. So we're going to talk about both of those. There's two main types of immunity, and those are active immunity, oops, I'm trying to draw, and passive immunity. Okay, so active immunity is when your body actually makes the antibodies. So that's what's going on. We're making the antibodies against the antigen. Okay, so it could happen if you were infected with something like chicken pox. Okay, so when I was little, we all got the chicken pox and we naturally became immune to them. Our bodies made antibodies to them. Now they give kids a chicken pox vaccine. Okay, so the chicken pox vaccine causes their immune system to make antibodies to it. So they've been immunized against chicken pox. Okay, so same kind of process is happening. It's just one is a natural infection and one we're infecting. We're not infecting them because a vaccine is usually not a live virus. It's an inactive virus. So we immunize them with a virus that doesn't cause an infection. Okay, so inactive immunity, the first exposure is short-lived and slower to respond. So it takes us a while to develop an immune response. But then the second time you get exposed to it, the response is really fast, and usually you don't get the sickness. Okay, so like if I got chicken pox the first time, I would get chicken pox and I would have, the fever and everything going on. And then after I healed, if my neighbor came over and she had chicken pox, the second time I would be exposed to it, I wouldn't get the sickness because my immune system would respond really fast. Okay, active immunity is usually long lasting. Okay, so chickenpox, when you're exposed to it or you get the vaccine, it usually lasts till you're about 50 or 60 years old. Okay, and it's totally dependent on the cells that we talked about earlier, memory B cells and memory T cells. Okay, so that's what establishes the memory that we have of the disease. Oops, I don't know why this looks like this, but it's real pale. But this is supposed to be showing you the suggested immunization schedule for kids. So it shows how hepatitis B, the DTP shot, all the different things that we vaccinate against. Okay, and then down here, this graph, which is on page 147 in your textbook, this graph shows how our body responds. So the first time we're exposed to the vaccine, like some vaccines we get twice. Okay, so like the DTP. The DTP we get, when we're 2 months, 4 months, 6 months, 15 months. The first time you're exposed, it causes a little immune response. Okay, so you start to make some antibodies. And then the second time we give the vaccine, it creates what they call a higher titer, so that you make more antibodies faster the second time you get the vaccine. Okay, so now passive immunity is we're giving the antibodies to somebody. Okay, so instead of their body developing the antibodies, we're giving them the antibodies. So some ways that this happens is when you're pregnant. Okay, so when you're pregnant, the antibodies, the IgGs, actually cross the placenta, and the baby has the antibodies in their body that the mom has for a while. Okay, some antibodies are secreted in breast milk. Okay, so that provides the baby with immunity against some things. Sometimes we inject antibodies. Okay, that doesn't happen too often. Sometimes it's used if like maybe you got an accidental needle stick and they wanted to make sure that you didn't have hepatitis. They might take take some antibodies and inject it into somebody that was accidentally stuck with the needle. Okay, now, how do we make antibodies? So one way that we make antibodies, which this is really cool for passive immunity, so to inject them into someone, the way that we make antibodies is, it's called monoclonal antibodies. So monoclonal antibodies, okay, they come from the plasma cells that originated from the same B cell. Okay, so we're going to do this in a petri dish. Okay, we're going to do it in like a test tube. So we have this plasma cell. This purple cell is the B cell. Okay, and it can make the antibodies that we want. Okay, so it can make the antibodies to the little green heart antigen. Okay, so in order for us to make them, what we do is we actually fuse that B cell with a cancerous cell that's going to reproduce uncontrollably. Okay, so we fuse them together and we make something called a hybridoma. The hybridoma is then able to grow like crazy, and it can produce tons of antibodies. Okay, so it makes a whole bunch of very specific antibodies to the antigen. Okay, and we don't have to use an animal or anything like that. It's all done in a petri dish. Okay, now, sometimes our immune system can actually, well, here, go back once. So some examples of monoclonal antibodies that are used in medicine today are things like RSV. So RSV is a virus that infects newborn babies, especially babies that are premature. They're really susceptible to this virus during like cold and flu season. So there's a company in Frederick, and what they do is they make monoclonal antibodies. They inject them into the babies, and then they're going to bind, okay, to the virus and take the virus out of circulation. Okay, so that kind of targets the virus so that it can be destroyed. Okay, now, how can the immune system react in a way that's harmful to the body? Okay, so there's several different things that can happen. Okay, so one is allergies. Okay, so if you have allergic reaction to something, it's a really strong immune system response. Okay, so it's a hypersensitive response. Okay, then we have tissue rejection. Okay, and then we also have immune system disorders. So we're going to talk a little bit about each of these. Okay, so allergies are categorized as being hypersensitive to something. So a normal person wouldn't have a response to it. It's something that could be considered harmless, but your immune system is oversensitive to it. Okay, so there's things that cause allergies like pollen, food, animal hair. Okay, the way that an allergic response occurs is that the IgE antibodies attach to mast cells and basophils. Okay, when that happens, we release histamine, and histamine is what's causing lots of allergy symptoms. Okay, so the runny nose, the runny eyes, the red eyes, okay, all that stuff. An immediate allergic response occurs when the allergen actually can enter the bloodstream. Okay, and that causes anaphylactic shock. So anaphylactic shock is really scary and can be deadly. Okay, so with anaphylactic shock, the respiratory system, the bronchioles start to close up, histamine's released, the blood vessels dilate, and your blood pressure drops. Okay, so it can kill you. So people that have really severe allergic reactions carry an EpiPen, which is epinephrine, and that will counteract the allergic reaction. You can have delayed allergic responses. So like if you're outside playing around and you wake up the next morning and you have a rash all over you, so that can be caused by memory T cells, and it's seen in things like poison ivy. Okay, tissue rejection. So all of our cells have markers on them that let our body know that there are cells. Okay, so that's how we recognize self. So what happens if you gave someone an organ, so say you gave someone a kidney, okay, their immune system, their cytotoxic T cells, don't recognize that kidney as their own. Okay, they say, oh, that's foreign material. I need to start to destroy it. Okay, so what we can do is we give patients immunosuppressant drugs, okay, and that suppresses their immune response, so the cytotoxic T cells don't fight it off as bad. We try to match the proteins on the surface, the MHC proteins. We try to match the donor and the recipient as close as we can to reduce the amount of immune response. Okay, we're also trying to grow organs in lab, not in a human body, and that there should be less rejection with that.